Okay, so I need to calculate the gradient of the line L, and I need to find a triangle under the line that has got a triangle which finishes nicely on a corner, so I can easily measure the rise and the run. Rise over run gives me a gradient of a quarter. Okay. Then I'm asked to calculate the equation of the line, and I know a straight line is y equals mx plus c, where m, the gradient, goes in front of the x, and the y-intercept is where it comes to the y-axis. So you can see I've got my gradient of a quarter, the y-intercept is 3, hence my equation is y equals a quarter x plus 3. Well, here, for the next question, I need that any line that's parallel to L must have the same gradient, and just as an example, I've shown you some others that have got gradient of a quarter, and you can see anything with a gradient of a quarter must be sloping in the same way, must be parallel. So that I know that my equation is y equals a quarter x plus c. My problem is I don't know what the c bit is. But they have given me some information. They've told me x and they've told me y. So I'm going to replace the y with minus 2 and the quarter with minus 4 and plus c. And I've used brackets to do that with. And minus 2 equals, if I put this into a calculator, which I recommend that you check, you'll get minus 1 plus c. And if I move the minus 1 over to the other side, it becomes plus 1, change sides, and I find that c is equal to minus 1. And therefore my final equation is y equals a quarter x. Sorry, you can't quite see that, so quarter x minus 1. Okay, so I come back here and I found similarities question and similar, and I found it easier if I break up the triangle and match up the letters with the correct corners. And I can see that this AB matches with the AC, and I can see by division that this one is 1.6 times bigger, and so AD will have to be 1.6 times bigger, and which gives me 12.8. This one is testing to see if you know that if the lines are bigger by 1.6, the areas will be bigger 1.6 squared, and if it had volume, this question, the volumes will be bigger by 1.6 cubed. So all you have to do is the area of the small one times by 1.6 squared, giving you 30.72. Now in this question, it's a histograms question. Okay, so the first thing I do is write down that the quantity is given to you by area, and then it's easier to think of the y-axis as heights. And here then, this section here must have an area of 4, okay? And if I do the area of 4 here, okay, and this has got a width of 5, what multiplies with 5 to give you 4, I calculated to be 0.8. That allowed me to work out the height scale, which I've written in here. Now the next area is 5 to 20, whoops, can't see that, 5 to 20, so I'm going to mark 5 to 20 in, so that gives me there, which means that the width here is 15, and my quantity is supposed to be 18, so I'm going to work out what is 18 divided by 1.5 gives me 12, okay, 12. So hang on, it's not 1.5, is it? It's 15. So that's what I'm going to say. So that's 1.2. That's better. Okay, so this means this would have to be 1.2. 1.2 is here. You should use a ruler, but for sake of time, I'm going to go like this. So there's my height there of 1.2. The next one is 34, and that's only 34, and it's a width of 10, you can see there. So 20 to 30, width of 10, 34, so 3.4 for that one. It's quite an easy one. Just move that up there so you can see what I'm doing. And so I'm just going to 3.4 and 10. Because 3.4 multiplies with the 10 to give me the area of 34. Quantity is area. And then we've got 30 to 50. Okay, well that's there, that's 20, and the quantity is supposed to be 30. Okay, so what's going to multiply with that? So 30 divided by 20. Okay, that's 1.5. So I need to go to 1.5, and this gives me 30 that I need there. Okay, so that's the histograms question. Heights times widths gives you quantity. And here we've got a bounds question, and I've written the upper and lower bound here, and the upper and lower bound here. Okay, and just to show you that some of you have got an instinct that the biggest difference will be the big one, take away the small one. Okay, but if you didn't know and you weren't quite sure, you could just work them all out, all the different ways in which you could do the subtraction, and you can see that it's the big take away the small that gives you the largest difference. And finally, we've got this question here, which is tricky because of two ends. Anyway, the first thing I did was get rid of the square root, which gives me t squared. Then I'm going to get rid of the fraction by multiplying in my mind both sides by n, which gives me nt squared equals n plus 3. And if you remember, the way you do it when there's two of these things is that you need to factorize. So I'm going to bring the n over, change sides, change signs. I'm going to factorize out the n, giving me t squared minus 1 equals 3. And then finally, I'm going to divide through by the whole bracket. Okay, and so my final answer is going to be 3 over t squared minus 1.